In this video, we shall be learning about the angle between two lines. So like this diagram shows, what it's talking about is this acute angle between two lines. And by by geometry, we know that the opposite angles, like when two straight lines cross, the opposite angles are equal. So this angle is actually equal to this angle by geometrical laws. Okay, so the angle between two lines is equal to, what we mean by M2, we remember that the gradients of lines are represented by M. So the gradient of the second line minus the gradient of the first line over 1 plus the product of the two gradients. So that the angle between two lines, so this formula was gotten by trigonometric relationships and everything. So no need to bother you about this, about how this formula came about. So, but this is basically the relationship between the gradients of the two lines and the acute angle between them. Now we are going to be using examples to see how we use this formula. And we are going to be seeing some of the implications that arise from this relationship. Here we've been asked to find the value of the acute angles between these lines. Okay, so let's first of all write out the equations of the straight lines. And we have to arrange it, because for every straight line, it's usually denoted by y equal to mx plus c. So we have to arrange it in such a way that it looks like this. So we have this, we have to make y a subject formula. What we have to do is, this y, since it's negative on this side, we have to cross it over to the other side of the equation. That is, we are going to have 3x plus 1 on this side is equal to, instead of negative y, it becomes positive y on this part of the equation. So having seen it this way, it means that if we look at it, if we compare the two equations, we are going to see that this is actually the gradient of the line and this is c, the constant. So from this, m1 is equal to 3. This implies that m1 is equal to 3. Then the second equation, we have x minus 2x plus 1. Something is wrong with this. Please, it's 2y. X minus 2y plus 1 is equal to 0. So let's arrange it. We have that x plus 1 on this side. Since this is negative, it goes over to this other side to be positive 2y. But remember that y has to be the subject of the formula, not just y and any other coefficient. Okay, so we divide all through by 2. When we do that, the equation will look like this. Half x plus half is equal to y. So this implies that m2, that is, this is the second equation, so m2 is equal to, did you see that? Half. When we compare with this. Okay, having seen this, we now write out the relationship between tan theta and the gradients of the lines. We have that tan theta is equal to m2 minus m1 over 1 plus m2 1. And this is the absolute value of this. So whether it returns positive or negative, it doesn't matter. Now let's substitute. We have that m2 is half minus m1 is 3. We have 1 plus m2 is half times 3. Half minus 3 is minus 2 and half, right? And then 1 plus half times 3, that is half of 3, is 1 and half, right? So we are going to be having that tan theta is equal to minus 2 and half over 1 plus 1.5 is 2 and half. So remember, it's absolute value, so negative does not matter. So my negative 2.5 divided by this thing, that gives us negative 1. But because of the absolute value, so this is 1. So all we have to do is we are going to find the tan inverse of 1. So tan inverse of 1 is equal to that angle between those two lines, and it's equal to 45 degrees. The tan inverse of 1 is 45 degrees. Now, having seen the relationship between the angle between two straight lines, there are some things we can derive from that. Those two straight lines can be parallel lines, that is like this. That means the angle between them is 0. And if so, if they are parallel lines, that means their gradients has to be equal. When we manipulate that relationship, make it equal to 0. That is that theta is equal to 0. Okay. Now, if they were perpendicular to each other like this, those two straight lines, they are perpendicular to each other. What it implies from that formula is that means they have angle 90 degrees. Here they had angle 0. So that means they have angle 90 degrees. So tan of the angle 90 degrees, that's infinity. And what it actually means is that the relationship now becomes that M2 is equal to negative inverse of M1, or whichever way. Any one of them can be any one of them. That means they are related by the gradient of one is equal to the negative inverse of the other. Now let us see how we can apply that. Determine if line AB is parallel or perpendicular to line PQ, each of the following. So let's start with the first one. So with the first one, we have, let's write out the two. So for line AB, we have 3, 1 and 4, 3 as the 2 points. So this is x1, x2, x1, y1, and then x2, y2. Okay, it's now for us to find out what the gradient is. And for line PQ, let's just write out the coordinate points 4, 6 and 5, 8. So this is x1, y1, x2, y2. Okay, now let's solve for the gradient of this first one. We have m1 is equal to, so let's write down the formula somewhere so we can always look at that, y2 minus y1 over x2 minus x1. Okay, so we always look at this. We have y2 minus y1, x2 minus x1. 3 minus 1 is 2. 4 minus 1 is 1. Then for this, we have that m2, this is the second line, m2 is equal to y2, 8, minus y1, which is 6. We have x2, 5, minus x1, which is 4. 8 minus 6 is 2. 5 minus 4 is 1. So we can see that m1 is equal to m2. And what does that tell us? That these two lines are parallel since their gradients are equal. Therefore, AB is parallel to PQ. That is what it means. That is, since M1 equal to M2. Therefore, so this is a full answer. Now let's look at the other one before we go. We have, so this was the A part. For the B part, we have, that's AB is equal to 5, negative 1, and then 3, 2. And then we have that PQ is equal to 2, 4, and 5, comma 6. x1, y1, x2, y2, x1, y1, x2, y2. Always write these things out so that it helps you to identify each of the values correctly. So we have that m1 is equal to y2, which is 2 minus y1, which is negative 1. m2, no, then the denominator becomes 3 minus 5. So 2 minus minus 1 is 3. That's 2 plus 1. 3 minus 5 is negative 2. So let's keep that aside. We have that m2 is equal to, we have y2, which is 6, minus y1, which is 4. We have x2, which is 5, minus x1, which is 2. 6 minus 4 is 2. 5 minus 2 is 3. Okay. So if we look at this, we can see that this has negative, this doesn't have negative, right? And this is an inverse of this. So we can see that m2 is equal to the negative inverse of m1, right? So we now say m2 is equal to negative inverse of m1. That is when we multiply this by minus 1, that means the minus cancels out. It becomes 3 over 2. And when we invert it, that is turn it upside down, it can now be equal to this. That is what we mean by m2 being equal to negative inverse of m1. Therefore, they are perpendicular. AB is perpendicular to PQ. So that is it for this video. We've seen the angle between two lines and how to calculate for that angle between two lines, and we've seen the applications of that relationship between the angle between two lines and their gradients, and we can use it to determine whether lines are parallel or the lines are perpendicular to each other, just using the formula. So your duty now is to practice, 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 and you become perfect.